Hi everyone, it's Matt Woods again, and I was looking through the old videos, and I think I might have mentioned domain and range in passing when I talked about functions before, but I want to make something a little bit more in depth because it's something that is important. So the domain of a function, all possible x values, they're your inputs. So what can I expect to put into an equation and be able to get out a legitimate answer? And when I say the word legitimate, I mean a real number. We're not looking for imaginary numbers or not looking for undefined numbers. And that will become a little bit clearer when we get a little bit deeper into this video. The range is all possible y values. So these would be your outputs. So what answers can I expect to get from a given function? That's the range. Now we're going to focus mostly on domain because that's where more of your restrictions are going to come into play. And there are two main ways that we're going to look at. Obviously, there are more than two ways to restrict a domain, and there are more than two ways to restrict a range, but we're going to focus on the main two that you're going to see on the placement. The first way is with a denominator. These cannot equal 0. So let's say we have this function, 1 over x plus 4. If this was just f of x equals x plus 4, it wouldn't matter what I throw in there. I can put in a negative number in that situation. I can put in 0. I can put in an irrational number like pi, and I can still get an answer. In this case, because we have something in the denominator, there's not going to be an infinite number. Well, I shouldn't say that, but there's not going to be an unlimited number of answers. There's going to be one thing I can put in there and not be able to get an answer out. So what is that one thing? Well, what I have to do is set the denominator not equal to 0. So this is also going to double as some inequality math. But just like typical, we're going to subtract 4 from both sides. X not equal to negative 4. Any other value I can put in here. I can put in negative 3. Negative 3 plus 4 is negative 1. Gives me negative 1. That's fine. I can put in something smaller than negative 4, like negative 5. And yes, I'm now just realizing that, okay, I'll fix it. I know there's an error in the very first video I did too. I never got around to fixing it. There. Negative 5 plus 4 is negative 1. That one I know. And I still get an answer out. It's not going to matter what you put in there as long as you don't put negative 4 in there, because what happens is you get 1 over 0. And if you put that into the calculator, you'll get something that says basically that it does not exist. So denominators, you set not equal to 0, and you solve for what it cannot be equal to. The other way is with radicals. And if these two sound familiar, it's because we just did our rationalization video, which I will plug there. And it's for similar reasons why we do rationalization. The less that we can limit the denominator, the easier it is to look at the function to think about it. So, for an example, f of x equal to square root of x plus 5. The key with radicals is that they can actually equal to 0. If you do square root of 0, you get 0. That's fine. But they cannot be negative. So what we do is we set them greater than or equal to 0. And what that means is I take this function in here, and I don't remember if I mentioned it in the radical video, but this is called the radicand. And we set that greater than or equal to 0. We're going to solve this just like normal. There'll be 1 or 2 times where you don't with an inequality sign, and we'll cover that as we see them. X greater than or equal to -5. So because this is greater than or equal to, that means I can put -5 in here. What happens when I do that? -5 plus 5, which is 0, that's fine. Greater than -5. So a number greater than -5 would be -4. I get 1, that's fine. But if I put in something like -6, I get square root of -1, which, if you remember from our imaginary numbers videos, you'll remember that this is the imaginary number, and that means that this does not exist. So that's what this sign is going to mean. Now, what happens when we have something like this? X squared minus 2. Well, again, we got a square root sign, so we know that the denominator cannot equal the denominator. I apologize. The radicands cannot be negative. So I'm going to do x squared minus 2 greater than or equal to 0. Let's add 2 to both sides. X squared. Now I'm going to take the square root. So now this will be a good time to remind you that if you put in the square root sign, you have to account for both positive and negative. And the way we do that for inequalities is this. We have x greater than or equal to the positive root. And we have x less than or equal to the negative square root 2. So remember, usually it would be, if we had it like this, we would say x equals the positive negative square root 2. This way we have to split it up because of the inequality sign. So anything greater than the square root of 2 on the positive side will work. Anything lower than the negative square root of 2 on the negative side will work. That means if I put in something like 3, -3 squared minus 2, -3 squared, remember, is positive 9. I get square root 7. Irrational, but a legitimate number. If I put in something that's greater than the square root of -2, like -1, -1 squared is 1 minus 2. I get square root of -1. Can't have that. So that's how you deal with the radicals when you're finding the domain. Now, there's one more that I should mention because it's something that could possibly pop up. What happens if you have both? So 5 over the square root of x plus 2. What this means is that not only can this not be, the denominator cannot be 0, but also it has to be, this x plus 2 has to be positive. So I cannot do square root of 0. So now if it's both, it's just greater than 0. No equal sign. Subtract 2. x greater than -2. So remember, this time -2 is not going to be a possible input, because if I put -2 in, I get -2 plus 2, which is 0. Square root of 0 is 0. So 5 over 0 is not going to work. But if I put in anything greater than -2, like -1, -1 plus 2 is 1. Square root of 1 is 1. 5 over 1 is 5. That's going to be fine. So that's how you deal with domain mainly. The next video I'm going to do is going to be on shifting, and that's going to have a lot more to do with how to manipulate the range. So with that, I will see you in that video.